Hi everyone, Mr. Zhang here. Today we're going to learn about nuclear reactions. Now, you might already know that there are two types of nuclear reactions. The first one is fission and the second one is fusion. And these are processes that alter the nucleus of an atom. Something you need to remember is all of this right here. This is really important. Okay, so X is going to be whatever atom, right, whatever element we're looking at. Maybe say isotope instead. And A is going to be your mass number. Okay, and then Z is going to be your atomic number, which is equal to the number of protons. Okay, so this is the basic information that you need to know about isotopes, right? So this is the stuff that you learned last time. Now, when the nucleus of an atom changes, that's called transmutation. Okay, and that includes fission and fusion. Okay, and they have to obey, right? They have to obey two very fundamental conservation laws. The first one is that mass is conserved, right? So 1, and then 2, that electrical charges is conserved. Electrical charges, right? So meaning, right? So here we have a positive charge, right, of 92, and then you can see that when they add together, it gives us 92. Okay, mass is conserved. You can see 238, 234, right? That's 238, 234. Oops, plus 4, that gives us 238, as written there, right? Okay, so these two rules, like these two things are what you have to remember when you are essentially writing down nuclear reactions. Okay, so this is a nuclear reaction equation, and we can tell that this is fission because something bigger is getting smaller, right? Yeah, okay. And then fusion is the other way around. Okay, so if you read through this, it's going to tell you what nuclear fission is, and then the other one's going to tell you about nuclear fusion. Of course, fission is when... Now, the way the fission happens is you have some kind of isotope, like a big one, usually, and then you have a neutron that enters the isotope, a pretty slow neutron, so that the isotope can actually capture it. Once it captures it, I believe the idea is that it's going to become unstable, right? So this word, unstable, right? So the nucleus is going to be unstable, and then it's going to break. So in this case, we get, I forget what this one is, baryon, and then this is krypton, right? And then the result is 1, 2, 3 neutrons. Okay, so this exact same thing that happens here is this reaction right here. So you have uranium-235 plus a neutron, and that gives us all of this. Okay, so these are examples that you can take a look at. So it says, what quantities are conserved in nuclear transmutation? Remember, you go right back up, mass and electrical charge. Right, so mass and electrical charge. Electrical charge. Okay. Next question. It says, the fission equation shows the production of many different elements, even though each reaction begins with uranium-235. Right, so they all, right? Uranium, and one neutron. How is this possible given the conservation reaction laws? Well, it's possible, right? Because there are different combinations, right? So you can do like 2, right? So we have 2 plus 139 plus 95. That's going to give us 235, right? Same idea, right? 3 plus 139 plus 94. Right? So you can see how like this one decreased by 1 and this one increased by 1. So that is how it's possible, right? And we can say variation. We can say variation of isotopes. Isotopes allow for different products, we can say. Right, so these will be your products over here. Right? As long as mass and as long as mass and charge are conserved. Okay. Next one, fusion. Now I'm just gonna go through a little bit of this, and then you and maybe do like one down here. Then you guys are gonna finish the rest of it. Next up, fusion. Okay, so it says fusion occurs when two nuclei join together. Right. So essentially, you have one thing plus another thing gives you this. Okay, so that's what fusion is. And here we're looking at deuterium. Right. So two deuterium atoms add together. It makes some energy in the process. All right, they fuse and they make some energy in the process, and then we get He and a neutron out. Now this is helium-3, which is different from helium-4. Okay, and then here are some examples that we're looking at. Right, there we go. This one produces a proton. This one produces a neutron. So I'm not even sure if this is right, because it should be helium-4, I believe. It should be like this. Yeah. Because otherwise the charge is not conserved. So I think this might not be right. But yeah, so you take a look here. You can clearly see the difference between these two, right? One of them is breaking down. And so you take a look at this. If you take a look at this one, you can see that it's breaking down. It's big and it gets smaller. This one is small and it gets bigger. Okay, the nucleus is getting bigger. Okay, so what's the difference between them? How can you identify each of them? Right, so fission is breaking or splitting. Maybe I'll say splitting. So the nucleus becomes smaller, and fusion is nucleus becomes bigger. Right, gets bigger. Nucleus gets bigger. Right, nucleus. Whoa. Nucleus splitting. How do deuterium, hydrogen 2, and tritium differ? Right, so how are they different? Well, it's the number, right? Number of neutrons. Okay, that's what's different. Remember, if the number of proton changes, then the element changes. Right, so it's the neutrons that are changing. Okay, so not proton. That's something you have to remember. And this applies for isotopes as well, like any other isotopes, right, that we're talking about. The fusion equation shows the production of atoms of different elements, even though reactions begin with isotopes of hydrogen. Knowing starting elements, can one predict what element will form? The answer is no, right? Because you can get many, and when I say many, a lot of variations. Many variations. Okay, so it's just not really predictable. Okay, so maybe I'll do question 6 and 7, and then you guys can finish the rest of it, right? Because the concepts are pretty straightforward. So here we have H, right? So H plus H, deuterium plus deuterium. We are going to get He 4 and 2. So this is helium, right? Helium. Now, how do I know that it's He? How do I know it's helium? Well, here's one proton, here's two protons, so 2 protons. And when you look on the periodic table, right, He is the one that has the number 2 here. And remember, number 2 here is the atomic, right? This is atomic number, which again is the number of protons. Okay, so if you go back up here, same thing I said up here, right? And bam, right? So that's how we know that it kind of has to be He, right? Then we're looking at the number of neutrons and we add them up together, which gives us 4. Okay, so this is fusion. Now this one is fission, right? Because it breaks into smaller. Right, so it wants to know, find the identity of X, right? What is X? All right, so in this case, the first thing that we want to do is to do 92 minus 60, because that's going to give us the number of protons, right? So that's going to be 32, right? So you got to look up a periodic table. So let's go. Right? No thanks. Okay, periodic table. Periodic table. Any periodic table should be useful, but let's take a look at this one. Okay, so remember the number we're looking for is 32, so it looks like it's going to be germanium. You see that? 32 right away. Okay. Now when you do this enough times, you'll know, right? So X should be germanium something, right? So now you know it's germanium, it's 32, and we want to know what the number of neutrons are, right? So here we have 3 plus 152, right? So 152 is going to be plus 3. That's going to give us 155 over here. So we want to know what the number of neutrons are here, right? Or what the mass number is, sorry. Not the number of neutrons. Let's go back up, right? So here it is, mass number. So I don't know why I said neutron. Okay, but anyways, so we have 155, and we want to know, so what we have to do here is what adds 155 is going to give us 236. Okay, so in this case, you just do 236 minus 155. This is 1, 1, 1 here. This gives us 8. Is that correct? Yes, 8. So it's going to be 81. So this is germanium 81. Okay, so I'm gonna circle this. Bam. Right, so that should be the right answer there. Feel free to double check to see if I did this right. Okay, but that's the idea, and you are going to go through this and figure out all of these guys. You'll see something like this, which is kind of interesting, right? So remember, you have to remember that the charges matter. So here, that the charges are conserved. So this is actually -2, right? -2 charge. And let's see, -2 charge. Sorry, let me take a look at my notes here. It's gonna be -2 charge, and you have to consider the -2 charge. So we know that all these three things, all these three isotopes or elements, I will call them isotopes. All these three isotopes are combining. So if there's a 2 in front, you have to think of it as there's a parentheses like this. Okay, so here there's a 1 here. It's invisible. So we don't have to worry about it. Okay, so you have 8, right? 8 and 4, and then 0 and -2, right? 2 times 0 is 0. Okay, and then you get 84. You get 214. So you got to add these together, right? So that's going to be 222. Okay, and then this is going to be 88 minus 2. So that's going to be 86. Now, what is 86? So you got to go here, and it's on our right side, 86 right here. Okay, so that's radon, I believe. Okay, so that's going to be Rn. Okay? I think that's the only one that is tricky that you have to know about. In case I didn't say this already, but these guys are neutrons, and these guys are these guys electrons? I believe they are. Miss Getz will correct me if I'm wrong about that. But yeah, yes, they are electrons because their mass is 0, right? So when we're doing nuclear reaction equations, we're gonna assume that like the mass of an electron is 0, even though it's not 0, it's just super close to 0. Okay, and I think that's all the information that you need. Right, so here we see an electron again. This one is a positron, right? The anti-electron is an electron. Okay, that should be all the information you need. This video is kind of long, so good luck.